Hello students, welcome to Dr. Shoraf's classes. In this particular video you can see we are solving the problem of these free response questions from AP Calculus BC. So before moving on to this particular AP, this problem solving particular question number 4, so let us understand what is this FRQ or the free response question. So for most of the students who are taking this advanced placement, so this is FRQ is one of the challenging part obviously, and it is the most significant part in increasing your which can have an effect on your overall score, right? So it is so much of importance. So those students who are really concerned with this thing and how to improve the this your score, particularly in this section, so here is a simple 5-point strategy which you can follow to score very good marks, and this decent marks you will get if you follow the strategy well. So first is thing is read each FRQ questions very carefully. So you must be careful in reading the questions. So you must understand what is the demand of the question, what the question is asking you to solve. So that is the understanding is very much required. Point number 2, you have to maximize your points on multiple parts question. As you can see here, I'm following the same simple strategy, multiple part questions. And point number 3 is the strategy 3, you can say that share the thought process, how you are thinking to solve the problem, what is your approach. You must be clear and concise. Okay. So what is the problem is saying, what is your approach, how will you move with this for the particular solution for this problem. And finally, usage of proper penmanship. Okay, so these 5 things are required. If you think that this 5-point strategy is the most simplest one, and if you follow this 5-point strategy, I'm sure that you will get a very good marks on the high end. Now the thing is that to be precise, so how to acquire this 5-point strategy, so you have to apply each the problem. If a question you're solving, you have to apply the 5 points, and only thing you can do this, you can achieve this only by practice. Okay, so that is all about the FRQ questions. So in this, now let us move to question number 4 this video. So this question number 4, you can see that the graphing calculators here are not allowed, so what you have to do by hand. So that is the question number 4 is saying that let f be a continuous function defined on the closed interval, that is -4 to 6. You can see, okay, this -4 less than equal to x less than equal to 6. So the graph of f consisting of 4 line segments, so this 1 2 3 and 4, this 4 line segments is shown above. Let g be the function defined by gx is equal to integral of 0 to x fx dt. Okay, so from here you can just infer from this, directly from the problem statement, you can say that it can be said that g prime x, okay, g of prime x is equal to fx, right, and it will be in any part of the response. Okay, so jx is will be fx. So if you do the antiderivative, you will find that g prime x is equal to fx. Now let's move to our part of solving questions part by part. So here it is given the first part, on what open intervals, okay, on what open intervals is the graph of g concave up. So give a reason for your answer. So first we'll solve the point A, the part A. So we have already the g prime x is equal to fx. Okay, so the graph of G is concave up for -4 less than x less than -2 and 2 less than x less than 6. So because this G prime is equal to f, so is increasing on these intervals. Okay. So that is the simplest part for this reason and as well as the answer. So the answer is open intervals of -4 to x to -2 and 2 and 6 in between this. So why? The reason, because this G prime equal to f is increasing on these intervals. So from this, so you can see that for the part A it is a 1 point, and since you have the model solution for any part of B, any part in the response, so that is you will get a 1 point. Okay, now let's solve the question B, part B. So part B is asking for that let P be the function, okay, defined by Px equal to Gx dot Fx. So you have to find P prime 3. So that is the function B. So we have the P prime x is equal to Gx F prime x plus G prime x Fx, right? So P of 3 is equal to P prime 3 is equal to G3 F prime 3 plus G prime 3 F3, right? So that is the product rule. Okay, now we have to evaluate the values of G3 or G prime 3. So we have to find the substituting G3, which is equal to this 0 to 3 ft dt. Okay, so it is equal to minus 3.5, and G of prime 3, it is equal to f3, which is simply minus 3. So into this, if we substitute this into the above expression, okay, for P prime 3, so it gives the following. So we will just put the values over here. So P prime 3 is minus 3.5 into 1 plus it is minus 3 of minus 3, so it is 9 minus 3.5, which is simply 5.5. So this is the answer. Okay, so in the for the product rule, we have this point of the distribution of points is getting over this 1 point. Next we have the substituting the value of G3 or G prime 3, so that is 1 point. And finally you have find the evaluated the value of P prime 3, that is the answer for this 1 point for the part B. So total 3 points of distribution over here. So let's see what the part C is question this part C is asking for. So we have to find, okay, so I have to find the limit x tends to 2 gx by x square minus 2x. Okay, so this is the part C. So limit of x tends to 2, x square minus 2x is equal to 0. We know that, right? Because this G is continuous for the interval this minus 4 less than equal to x less than equal to 6. So we have to use the L'Hospital rule, you can see. So this is the limit x tends to 2, g of x is equal to integral of 0 to 2 ft, which is equal to 0, since it is continuous. So therefore the limit, that is limit x tends to 2 gx by x squared minus 2x is an indeterminate type, indeterminate form of type 0 by 0. Okay, so that is the usage of the L'Hospital rule. So now using the L'Hospital's rule, so we have this limit x tends to 2 gx by x square minus 2x. Okay, so we will do the derivative of this. X tends to 2 g prime x, in the denominator will be 2x minus 2 simply, right? So g prime x is f of x for any part of the response. So this is 2x minus 2. So if we f of 2, this value of the limit, if we substitute over there, so f of 2 by 2. So f of 2 is minus 4 by 2, which is simply minus 2. So that is the value of the limit. Okay, so the first part is the, here we have given the explanation, that is the, we have to use the L'Hospital rule, and this particular limit is indeterminate of the form of the type 0 by 0. So for this we have this one point of the distribution of point will be here, this 1 point, and the second one we have given the, we have find the answers over here using the L'Hospital rules, that using with justification. So this will be of 1 point. So in the part C we have total have this 2 points. Okay, now let's check, let's see what the part D is saying. So we have the 4 parts of this question. So the part D is asking for, okay, so find the average rate of change of g on the interval minus 4 comma 2. Does the mean value theorem, the MVT, guarantee a value c where c is minus 4 less than c less than 2, for which g prime c is equal to this average rate of change? So we have to justify this answer. Okay, so let's solve this question, part 8, part D. It's part 4 actually. So g of 2, from here you can find, so it is 0 to 2 ft dt, which is equal to 0, and g of minus 4 is 0 to minus 4 ft dt, which is equal to minus 60, right? So the average rate of change, average rate of change, it is g2 minus g of minus 4 by 2 minus minus 4, so which is 0 minus minus of 16 by, it will be 6, right? So simply we can write the simplified, so 16 by 6, which is 8 by 3. So this is the average rate of change. Okay, Now we have to justify the answer. So that is the thing. Okay, so first you can see that we can write that g prime x is equal to fx for all part of the response. So g is differentiable on this particular interval minus 4 comma 2 and continuous on the open interval, on the closed interval minus 4 comma 2. Okay, so it is minus 4. So it is differentiable on this open interval and continuous on the closed interval, right? So therefore the mean value theorem, that is we can say in short the MVT, that is the mean value theorem, okay, so this applies and it will guarantee a value of c where c is in between minus 4 less than c less than 2, for which this g prime c, it will be equal to 8 by 3. Okay, so that is our answer with justification. Okay, so that's it. You can see the first part we have to find the average rate of change, so that gives 1 point, and here in the second part we have this given the answer with justification, that is go for the 1 point. So we will have this. Okay, we can write it in a better way. Okay, so that's the 2 points for the part D. Okay, so that solves our question number 4. Okay, so which have 4 parts over here, and you can see we have also remember that here the graphing calculators are not allowed.